Extracting gold from oxidized ore requires an industrial-scale chemistry operation. You crush the raw rock, pile it into enormous terraced heaps, and then run a liquid solution through the soil to pull the valuable metal out. Mapped on a flowchart, the system hinges on a single divergent fork, the dosing phase. This is when you introduce the chemical reagent to the ore. Your exact chemical choice dictates processing speed, safety liabilities, and total output. Because it sits directly at the center of the workflow, any optimization at the dosing stage ripples outward to impact the financial viability of the entire mine. For over a century, the industry standard for dosing has been cyanide, a highly toxic compound that requires heavy hazard management. Recently, an innovative, completely non-toxic alternative chemical called JIN CHAN has entered the market. For a mine operator, this creates an immediate operational dilemma. Does swapping a proven toxic standard for a non-toxic alternative require a financial compromise, or does it offer a competitive advantage? To evaluate this, we are looking at operational data pulled directly from the Guizhou gold mine's oxidized ore processing facilities. They ran a head-to-head performance test, evaluating both chemicals against a baseline of 1,000 metric tons of ore. We are going to look past the environmental PR and evaluate these two options strictly on their operational return on investment. That means analyzing three specific metrics. First, the processing time, their chemical consumption, and final recovery yield. This 1,000-ton dataset provides a concrete benchmark to see how green chemistry actually performs against legacy methods in a real-world environment. The first major operational metric to evaluate is processing velocity. This comparison table tracks the reaction speeds. Standard cyanide has a slow extraction timeline. JIN CHAN reacts much faster and completes its extraction significantly earlier. The data shows this faster reaction saves 3 full days of leaching time per 1,000 tons. That saved time frees up operational bandwidth, allowing a site to cycle through more ore in the same quarter. To take advantage of this, management has to overhaul legacy timeline expectations and shift schedules to match the faster chemistry. The second metric is total chemical consumption. Processing 1,000 tons of ore with cyanide requires a specific baseline volume of toxic chemical to achieve saturation. Looking at the consumption data, you need significantly less JIN CHAN to process that exact same 1,000-ton batch. Buying, shipping, and storing less chemical directly reduces the supply chain burden and lowers operational overhead. However, because the compound is so efficient, engineers must physically recalibrate existing dosing machinery to handle the lower required volumes. Between the 3-day time savings and the lower material volume, the data shows that moving away from cyanide can reduce baseline operating costs. But time and volume savings are secondary to the most critical metric for any operator or investor, the final recovery rate. The Guizhou mine data reveals that CHAN actually extracts more total gold, peaking at an 89%. Tearing up standard operating procedures that have been entrenched for over 100 years requires immense institutional effort. An entire workforce whose safety drills and emergency protocols are built around cyanide must undergo extensive retraining. Modern operators face a choice between achieving these superior yields or maintaining the comfort of their existing status quo. The takeaway from the Guizhou facility is clear. The non-toxic option delivered higher yields and faster processing in this head-to-head test. We can map out this data on a strategic scorecard to help operators determine their readiness to adopt this chemical shift, starting with new or expanding mines. Because these sites are building their protocols from scratch, they face zero transition friction and can establish an optimal baseline ROI from day one. Next, we look at ESG-focused portfolios. Financial analysts can use this data to target that 89% yield while removing the financial liabilities and insurance premiums associated with toxic hazard spills. Finally, we have legacy operations. Highly rigid legacy sites have to weigh the financial upside against their organizational capacity to retrain a large workforce. The chemistry performs as advertised, but the cultural resistance within older organizational structures is a real hurdle that management must plan for. The Guizhou gold mine results show that the non-toxic route offers specific advantages in speed, consumption, and recovery, leaving organizational inertia as the primary obstacle to adoption.